All right, so like I said, today we're going to be talking about relations and functions. And so when talking about this, let's talk about what in the world is a relation. So the first thing I want to do is we're just going to make a couple of boxes here. Okay. So just a couple of boxes, kind of like a Venn diagram thing. We'll talk about that in a minute. In this first box, in this first set, so these represent sets, we'll have cows and goats. Cows and goats in that first set. Okay. And then over here, we're going to have burgers. We're going to have cheese. And we're going to have lamb chops. Y'all following me so far? Okay. So we got cows and goats over here. We got burgers, cheese, and lamb chops over here. This first set, we could call this a set of animals. Okay. And we could call this set over here food. Y'all following me so far? Okay. Now, we could say, okay, cows, they can make burgers, and cows can also make cheese. All right, you see how I'm drawing this line? These lines, this is what we call a mapping. Okay, we're saying that cows map to burgers and cows also map to cheese. Does that make sense? And goats map to cheese as well, right? Because you can make goat cheese like feta cheese. And goats also map to lamb chops. Everybody got this down? This is an example of a relation, okay? So let's write this definition down. So a relation is just a mapping of two sets, or you can say of the elements of two sets. What's an element? It's just something that's inside of the set. So cows would be an element of animals, the set of animals. Does that make sense? Cheese would be an element of the set of food. All right. So it's just a mapping of the elements of two sets. Cows to burgers, cows to cheese, goats to lamb chops. Okay. This is what a relation is. It's just a relationship between the elements in these sets. Y'all follow me so far? All right. Now a function is a relation, but it's got one specific restriction. A function is a relation where the inputs map to a distinct output. And I'll explain what that means in a minute. All right, so if we think about it like this, we could say the animals, these could be our inputs, right? Because you can't get the food, you can't have the burgers and the cheese and the lamb chops without the animals, right? So we could say this is our set of inputs, and we could say the food, that's our set of outputs. Okay. Everybody following me so far? All right. So we got inputs, we got outputs, we got animals, and we've got food. Okay. So this is not a function. I'll explain a little bit later why this is not NOT, not a function. But for now, all we need to know is kind of like, think about inputs as something I put in, and think of outputs as something I take out. And I'm about to show you an example that will make things a little bit better. Okay, so we've got the McDonald's factory here. At McDonald's, what is McDonald's real famous for? Fries. What else? Big Macs. For what? Oh, Yeah, that too. All right, so we've got to make burgers, okay, and this is going to be a really sad looking cow. But to make burgers, I know this is kind of morbid, and hey, I got my cow, it's got some spots, you know, and stuff. It's kind of a sad looking cow, but all right. Well, it is a sad looking cow. But anyway, so cows go into my McDonald's factory and burgers come out. That makes sense? All right. So I put cows into my factory and burgers come out of my factory. All right. We're putting cows in, getting burgers out. But McDonald's makes more than burgers, don't they? They also make, for example, the fish fillet sandwiches, right? Or filet o fish sandwiches, right? Got sandwiches, these little square things. So to make those sandwiches, you got to put a fish in. So this kind of sad looking fish. The fish goes in, the fish filet sandwich, filet o fish sandwich comes out. Okay. Another thing that they make is chicken nuggets, right? They make chicken nuggets. And so to do that, they got to have chickens. And this is going to be one ugly chicken, but I'm going to start with the feet, try to get that together, and then kind of have a little body here kind of thing. And then we got the head kind of sort of looks like a duck, but you get the idea. So we got chickens going in, and we've got chicken nuggets going out. All right. So once again, we got fish going in, and we get the fish fillets coming out, the filet o fish coming out. We got the cow going in. We got the burgers coming out. We've got the chicken going in, and we got the nuggets coming out. Everybody following me so far? This is an example of a function, okay? This is an example of a function. It's a very basic function, but it's definitely an example of a function. All of these things that we're putting in, once again, these are called inputs, okay? So an input might be a cow. A cow could be an input. Fish could be an input. A Rhode Island red chicken, that could be an input. The range of inputs, the list of inputs, we call the domain. Okay, so a list or a set of all of the inputs is called the domain. So in this case, we could say that our domain is fish, cows, and chickens. Fish, cows, and chickens. Y'all following me so far? All right. Now, what we're getting out of our factory is called the what? Outputs, right. Yeah, you're definitely thinking where I'm going with this. So what we get put in, we call input. What we get out is called output. And the range of those is just called the range. The list of all the outputs is called the range. So in this case, the range would be fillets, burgers, and nuggets. Okay. Now, if the range only has fillets, burgers, and nuggets in it, okay, would iPods be in the range of this function? No, it wouldn't be in the range of this function. Would, for example, foxes be in the domain of this function? Foxes. McDonald's make something with a fox? I mean, we could get into that. You know, it's like, you know, people say like, yeah, squirrel meat and different things and whatnot. But, you know, and you don't want to know what's inside of a hot dog. But all the things, besides that, I'm just saying, like, for our intensive purposes, would a dog go into my domain? Would that be a part of my domain? No, not in this case. We got only fish. We only have cows. We only have chickens. Okay, but you know, a cow definitely is part of my domain. A Big Mac would definitely be a part of my range. Does that make sense? Okay, so this is an example of a function. Now, more importantly, a function is very distinct. In other words, every time I put in cows, I better get out burgers. Y'all see what I'm saying? So every time I hit cows, I put cow into my function, I better get out burgers. If I created a function where I got cows, I could put in cows, I got burgers, and then maybe sometimes when I put cows into my function, I get milkshakes out, that would not be a function. Okay, so let's think about that for a second. So if I had, I'm going to erase this real quick. All right, if I had a function, say, where I got cows, all right, and I've got burgers and I've got milkshakes, or just milk and straw. This is not a function. Why? Because when I hit cows, I might get burgers. When I put cows in, I might get milk out. Okay? When you type the letter S on your keyboard, okay? The only thing that pops up on the screen is S. Does that make sense? Okay? So for it to be a function, I'd have to have something like, if I have cows and then just milk or something like that, or actually let's do cheese. If I had cows in my domain and I got out cheese, okay, well, this is a function because every time I put cows in, I only get cheese out. Y'all following me so far? Now, what if I put goats also into the domain and I got out cheese? Guess what? This also is a function. Why? Because, so this is a function. Why? Because every time I hit goats, I only get out cheese. Every time I hit cows, I only get out cheese. Does that make sense? If every time you input something, you always get that same output, it's a function. But in the first example, when I hit cows, sometimes I got burgers. When the first example, sometimes when I hit cows, I got out milk, right? That's not a function. A function is like on your keyboard. Like every time you hit enter, you have it enter happens on your keyboard, right? You got two enter keys on your keyboard. Do you see that? There are two enter keys on your keyboard, the two shift keys on your keyboard, but they still, every time you hit shift, the same thing happens. Okay, that's what a function is. A function is every time you put in that input, the same output happens every single time, even if two different inputs map to the same output. Y'all following me? Okay, so every time I hit cows, I only get cheese. Every time I hit goats, I only get cheese, even though they map to the same thing. It is a function because every time I hit cows, I only get out one output. That's cheese. Okay. So if you had on your keyboard, you hit S, you got S out sometimes, you got T sometimes, that wouldn't be a function, right? Since every time I hit S, I only get S, that is a function. All right, so I know what you're thinking. Mr. Brooks, okay, I see what you're saying about cows and goats and cheese and chickens and McDonald's and all this stuff. What in the world does that have to do with math? Is that what y'all thinking right now? All right, so what if I had the set S? So write this down. I've got the set S, and this set has the ordered pairs 1, 2, 3, 4, 5, 6. Now, these things that I'm writing out, these are all called ordered pairs, right? You heard about that before, ordered pairs. An ordered pair is just a fancy way of writing inputs and outputs. In other words, what these three ordered pairs are telling us is when I input 1 in, I get out 2. Okay, right? When I input 3, I get out 4, and so on and so forth, right? These inputs, these are represented on a graph by X values, right? So like 1 would be X in this case, would be my X value, and outputs are represented by Y values in a graph. Y'all following me so far? Okay. So let's think about this. The domain, according to your notes, what you wrote down, your domain is your set of what's, guys? The inputs, X values, absolutely correct. So the domain in this case would be 1, 3, 5. Y'all see that? The domain would be 1, 3, 5. Why? Because that is the set of inputs, right? Remember, domain, that's my inputs. The range would be 2, 4, 6, because these are the outputs. That's the set of outputs. Does that make sense? Or Y values. So the domain in this case would be 1, 3, 5. The range would be 2, 4, 6. Any questions on that? All right. We've got domain, we've got range. What if I had this set at S? And what if my set was 1, 2, 2, 2, 3, 2? First question is this a function? Some people think no. Anybody, any other thoughts? I'm not saying it's right. I'm not saying it's wrong. But what do you think? Yes. You do think it is a function. All right. Why don't you guys think it's a function? For those of you who don't. I see what you're saying. Why do you think it is a function? Yeah. So here's the answer to the question. I'm sure y'all are wondering. This is a function. Why is it a function? Because remember, every time I hit 1, I only get out 2. Every time I hit 2, I only get out 2. Every time I hit 3, I only get out 2. The definition of a function is each input has a distinct output. In other words, every time I hit an input, I better get that same output out. Okay? So even if all 3 of these inputs go to the same output, that's okay. Because every time I hit 1, I will only get out 2. Does that make sense? I hope so. So in this case, the domain would be what? 1, 2, 3. What would the range be? Just 2. All right, y'all see that? It's just 2. Yes, this was a function. Okay, because each input still only has 1 output. Every time I hit 1, I'll still only get out 2. You know, if I hit 1 again and then got out -1, yes, that would not be a function. So what if my set was like this? 1, 2, 3, 4, 3, 2. Would this be a function? Why not? Yes. So since you got 3 and you get out 4 sometimes, and then you put 3 in again, you might get 2 out. This is not a function. Y'all see the difference? Okay. So if you have two different points where the input matches up with different outputs, it's not a function. In other words, when I push, think about it as an input is like a button you push. If you push 3 down, then you get out 4. If I push 3 down again and get out 2, that's not a function. Hmm. It's not a function. Now, if I push 3 down and got 4, and then I push 3 down and got 4 again, that would be a function, because every time I push 3 down, I only get out 4. Does that make sense? But because I pushed 3 down and got out 4, then pushed 3 down and got out 2, that's not a function. If you look back at the last one we did, when I push 1 down, I always get out 2. If I put 2 down, I always get out 2. If I put 3 down, I always get out 2. If you're trying to figure out if something's a function or not, look at the inputs. What's happening? Am I always getting the same number out every time I push, or every time I press that input button? That makes sense? Okay, great. All right. So we talked about domain, we talked about functions, we talked about range. The last thing I want to talk about is graphs. All right. Now, because functions have this very specific issue, let's think about it. The inputs are represented by my x-axis, right? That represents my inputs. And the y-axis represents my outputs. And we know for every input, I can only have one output. So in other words, let's say we're at, I don't know, 3 right here. And let's say this is 2, and let's say this down here is -2. Let's say that I've got at 3, I hit both 2 and -2. Would this be a function? No, because my input sometimes will be 2. My input, or sometimes I would get out 2. If I press 3 down, I sometimes would get out -2. So that cannot be a function, right? So here's the deal. The vertical line test says if you can draw a line, you can draw a vertical line, and you hit only one point every single time, no matter what vertical line you draw, it's a function. All right. So in other words, let's say I have this thing right here. Let's say I've got this function. Okay, it's got a curvy thing. All right. And if no matter what vertical line I draw, I will never hit more than 1 point at a time. Y'all following me? So therefore, it is a function. All right. So since I always only hit 1 point drawing this vertical line, it is a function. Okay. Now, if I had something like this, let me erase this piece. If I had something like this, would this pass the vertical line test? No, because right here, I can clearly see I'm going to hit 2 points. And that's it. That's what the vertical line test is.